Welcome to the AI Files podcast, your ultimate destination for staying updated on all things artificial intelligence. You can find us in Apple Podcasts as well as YouTube. I'm Shadab Hussain, co host of the AI Files. I'm the director of data and AI at Microsoft with over 22 years of experience in the analytics and AI field.
And I'm Jamie Basilico, co host of the AI Files with Shadab. As a data and AI technical specialist and architect, I have over 35 years of expertise in data related and AI domains, having worked with many Fortune 500 companies throughout my career. Please note this is not an official Microsoft channel. The views and opinions expressed by the co host are their own and do not represent the views of Microsoft. Today, we're going to walk through a very interesting topic, and that's around agents. To help us understand these concepts, we've invited back a brilliant engineer to share his insights. Today, we're thrilled to have back Simon Lacasse with us. Simon is a global black belt of AI at Microsoft, a title and honorific that signifies the depth and expertise and experience that he has in AI. With that, I'd like to bring him on stage, and we'll get started talking about agents.
Hello, Simon. Welcome
Hi,
back.
how's it going?
Great. Awesome. Thanks for coming back for a probably the most trendy topic AI agents.
My
So,
favorite topic for sure. So I'm happy to be back on to talk about this.
I think it is everybody's favorite right now. Nobody even knows how big it could be. So very excited to do that. So Simon, the AI agent is the most trendy topic of the day. What is it really? Why there is so much fuss about it?
Well, from a pure definition perspective, really what agents are what we see here in this quote: the study of agents that receive percepts from their environment and perform action. That's a very high level definition of agents. But what I like about this quote is that it was published in a book called Artificial Intelligence: A Modern Approach by Stuart Russell and Peter Norvig. And what's interesting is it says here that we define AI as the study of agents that receive percepts from their environment and perform actions. And what I also really like about this quote is it was published in 2003, right, where agents weren't even a thing back then. So it's interesting to see how AI is evolving into this kind of agent world where we have agents who have the ability to perform complex tasks and have the ability to leverage things like Gen AI and large language models, which is going to be the purpose of the discussion today.
I
So,
have this book. That's actually a gold standard on AI and machine learning, actually. So yeah, thank you.
yeah, it's amazing too that it was over about 20 years ago that was actually put out there. So I guess my question to you, Simon, would be, all right, great. We looked at that definition, but what really is an AI agent? Like what it is it at its core?
Yeah, and like if we look at agents now in the world of artificial intelligence, an AI agent is really an intelligent software program that can interact with its environment. It can collect data. It can use data to perform um, tasks to meet predetermined goals. And these goals are, typically set by humans, but from an AI agent perspective, they have the ability to independently choose the best actions that it needs to perform to achieve these goals, to have the ability to perform even better orchestration and automation. So, for example, consider a contact center agent, AI agent that wants to resolve customer queries. Uh, these agents would have the ability to automatically ask the customer different questions, look up information in internal documents, for example, and respond with the solution. And based on the customer's response, it can determine and resolve the query itself or pass it to a human to try to solve the problem. Now, using intelligent systems for orchestration and automation isn't something really new, right? I'm sure you've all, have heard about robotic process automation.
Yes, been around.
Yeah, exactly. And so the reality is we've been trying to do this for decades, right? And with the advent of RPA, robotic process automation, we saw significant strides in this evolution, and it enabled us to automate repetitive tasks and streamline processes. But an RPA agent uses rule-based computer programs to basically execute logic and perform actions. And although they've been proven to be really effective, they often face limitations in their ability to adapt and learn autonomously, especially in the context of multi-step decision-making problems. And as a result, traditional machine learning and things like reinforcement learning techniques were applied to these RPA agents so that we gave them the ability to learn, but it still proved rather quite difficult from a traditional machine learning approach and using reinforcement learning, where it can be quite complex and it requires a large amount of data and sophisticated retraining techniques to make these models understand what they were doing and have the ability to learn. So I feel that's changed quite significantly now with the large language models and Gen AI.
I see a lot of agentic framework and probably some sort of an architecture diagram on your whiteboard actually behind you. So like you said that it has been around. So what has really changed in this new generation of AI that wasn't really happening earlier, right? I mean, what is that, like the flow of how it has to be worked, or has it become more intelligent? Is it become more self-driven? What really has changed with the LLMs?
Yeah, and that's a great question, and it's where I believe it becomes very interesting, right? Like, if you look at the realm of automation, we're really in the midst of an enormous transformational shift at this point, and transitioning from these traditional non-LLM based agents or RPA to now more advanced dynamic and adaptive learning agents powered by large language models. And I feel like this is it's a massive leap forward in the field of automation. So like with LLMs, we're not just automating tasks, we're automating learning, decision making, and adaptation. And we're essentially creating models that can interact with the external world. They can absorb new information, they can modify their actions accordingly, and all of this in real time. So let me demonstrate to you why this is possible today. Okay, let me share my screen again here. Give me 1 second.
Yep. Picture says 1,000 words and video probably says million words. Or should we talk in terms of the tokens rather than words now?
Yeah, exactly. So let's look back at the definition of agents, right? Before I provided a very high level, overview of what an agent is, but what is really an agent from an AI perspective? Well, the reality is that agents, from an AI perspective, leveraging large language model or Gen AI, they have the ability to take actions. We all know that a ChatGPT model, for example, can generate emails, right? It can write documents. It can even code, right? It can even write programs. So they have the ability to take actions, right? But they also have the ability to have memory, right? They have the ability of keeping a short-term memory or a long-term memory, and they could use that for future interactions with these agent systems, and they can learn over time, which makes them really interesting. They also have the ability to plan. They have the ability to decompose tasks into smaller tasks, which is very important, and we'll talk about that later. But they also have the ability to provide a certain level of orchestration where they can coordinate the functions or the tools that these agents have, and they can coordinate the agents that are part of the system to automate or orchestrate certain tasks. They can be interactive, they can be event-driven, there could be a human in the loop at certain points of the interaction where sometimes a human is needed for feedback or for additional data or other things like that. Let me explain that a little bit better. Let's take an LLM, for example, right? We all know that today these LLMs have been trained on quite a lot of data, and they have a lot of general knowledge, and they can mimic certain, human reasoning capabilities, right? And one really interesting thing about LLMs like ChatGPT is they can actually learn in real time about new data or new situations, and we know this through things like in context learning, right? When you use a ChatGPT model, you can go and you can actually give it a whole bunch of text, and you can ask it to summarize it. You can ask it to write to create a Q&A chatbot over this knowledge. And we call this in context learning, right? Where you bring in data into a prompt and you have the model use that data to perform a certain task. And what that gives us, it gives us the ability for these large language models to have an external reality based on external knowledge, right? And that knowledge could either come from an internal knowledge store. So imagine an enterprise that has these knowledge bases about customers or certain procedures that they have to do or information that they have in these internal knowledge bases. We can feed that information into these LLMs so they can learn about that new data, right? And they can also have the ability to go and explore and find new data, right? You look at a model like Bing Chat, right? It has the ability to search the web and gather new information that it can bring into this model so that it can learn about this new information that it searched over the web. So in reality, these LLM agents have the ability to have an external truth or have access to external knowledge, which makes it really interesting. And we know today that we can do this through things like in context learning, through prompt engineering, and we also know that we can do this with maybe more sophisticated approach where we're using a RAG approach, or retrieval augmentation generation approach, where we use vector stores to be able to pull in the right information in these LLMs so that they could use it to reason further for a task that they're trying to do. But that's not all, right? Like we also know that we can give these models the ability to take actions, right? They have the ability to call out tools that they have access to, right? And those could be semantic functions, right, or native functions. So these LLMs could have access technically to an API that calls another system that is potentially maybe a customer relation management system, right? So they have access to these tools, and with that, they can perform actions. They can execute code. They can execute functions out of these systems. So they actually have the ability to take actions. And not only that, these LLMs, once they have access to this set of tools, they can semantically decide what tool they need to be able to solve the task that they're trying to solve. So they can say, well, I need to access a CRM. I need to access a loyalty database, right? And depending on the tools that these agents have access to, they can actually figure out what they need to call or what tools they need to call for, and then perform these actions on their own, which makes it really interesting. And again, we know we can do this kind of stuff with things like function calling and ChatGPT, where you can ground the models with functions, and this allows these models to be able to connect to external systems. So now we know that we can connect these models and give them access to knowledge, but we can also give them access to tools so that they can actually execute and take actions. But it doesn't end there, right? Like we know that these models can do a lot of things. They have access to tools, but they can take actions. And an action could be to generate an email, write a summary, right? We know that these models can do all of that. So they can actually take actions based on the tools and the knowledge that they have to be able to execute the task. And not only that, is these LLMs through in context learning, right, where the same principle applies to when you bring into knowledge into these ChatGPT models, you can actually have them have a certain type of memory, and that could be short-term memory, long-term memory. So what we could do is we can actually persist the actions that these agents are taking and use that as a short-term memory or long-term memory. So in other words, now these LLMs are using memory to make themselves even better and to learn over time. So In other words, sometimes maybe it already knows that knowledge, or it doesn't know that knowledge, right? And they can grab that information, but it learns over time about that, and it gets better, and they can iterate over that and use that memory to make themselves better over time, which makes it really interesting. Now, uh, another thing, we all know that we can give these models like ChatGPT a personality, right? I can tell a ChatGPT through a system message and say that you are an AI assistant that is really good at doing web searches, right? Or you are a creative AI agent that creates marketing material, right? And we can give these models a personality. And in agent world, it's very important, right? Because we may have agents that do different tasks and maybe have different personalities or have access to different knowledge, right? Where now you have these agents that are kind of domain specific and or experts in a certain domain, and they all have kind of a personality or a profile that they use to make themselves create outputs that are very personalized based on the personality that they have. Now, these agents, like I said, they could be interactive, they could be event-driven, there could be a human in the loop, it could be fully autonomous, where you have a bunch of agents working together to try to solve a problem. But one other really important thing about agents, and I feel that when you look at one of the main reasons why agents are so popular right now in LLMs and things like Gen AI is these models, they have the ability to create plans, right? They have the ability to take a problem and decompose that into subtasks, and they are able to execute that. And we know this actually through things like techniques like prompt engineering techniques like chain of thought. And for those of you who have never heard of chain of thought, it's a technique that gives the model time to think, okay? And it's very powerful, and in fact, it's actually chain of thought is one of the probably the most viral prompt engineering technique for these models. But what that means is that, let's say I ask the model to create a report of the latest company financials, and if you simply tell the model to think step by step, it gives the time for the model to think further, right, and really reason over the actions or the tasks that it's trying to do. And what that means is, for example, let's say the problem is to create a report. We can ask the model to decompose that into subtasks and create a plan out of it. So in other words, maybe the model here would decide that it needs to access a financial report. It needs to do data extraction, and then it needs to analyze that data to be able to come back with a financial report. So the model has the ability to think and to take a problem and decompose that into subtasks, which allows the model to execute much more complex tasks and to create these really sophisticated dynamic plans. And it makes it really interesting because now the model actually knows what kind of tools or knowledge it has or kind of memory it has, and it's able to devise these plans based on the agents or the tools or the knowledge that it has at its disposal. And it makes it really interesting. So I'll show you in a couple of examples later how we can use these inherent kind of features of these LLMs to create plans, dynamic plans, and to execute orchestration automation through a multi-agent system.
Simon, this is a great representation what you're showing here. Even the previous slide, I have actually a couple of questions on the previous slide. If you can go back somehow, you showed that really good representation of what an LLM agent is. It has knowledge, it has memory, it can take actions, and it has access to tools. And in that in that representation, just to I think break it down for our audience a little bit, I think the knowledge and actions, that components you can do with non-agentic applications today, right? So you can create a simple AI app in the, let's say, Azure AI Studio. You can give that a RAG ability and ask it to do some actions. But really, where I think the differentiation comes between an AI app and an agentic app is the access to memory and tools and ability to do self orchestrate and drive things, right? I think that's a key differentiation. The other thing I also wanted to ask, you talked about the learning, right? And it is learning really based on the knowledge, the internal knowledge and the external knowledge. So it's really a RAG based learning. It's not a permanent learning in the terms of, it's not fine tuning itself. But can it fine tune itself? Can the agent, this framework, fine tune itself rather than having to rely simply on the RAG?
Yes, and that's where you get into that memory concept that you see here, right? So you can persist the learnings or the output that these models produce, and by doing that, you actually are using that memory for every interaction so that the model actually learns on how it was able to solve a task previously or the data that it had access to. And we do this by persisting those interactions into a memory store or a vector store, and we pull that knowledge in real time when those agents are being executed, so that it actually knows on its previous actions or how it was able to solve a problem. So in other words, we are kind of fine-tuning these models in real time by using the memory that we've persisted in previous interactions. Of course, there are other techniques to do that, things like reinforcement learning or even fine-tuning these models, but those can get pretty complicated. So by using in-context learning to feed the model with real-time information about what it's learned in the past makes it a lot easier to adapt these models and have them learn over time.
Great. Okay, thank you. I think this was a great explanation. I was really curious about that. So we hear a lot about the single agent, multiple agents, and all those kind of frameworks and terms. How does that work really?
Yeah, and to piggyback on what you said before, right? Like, yeah, an agent, we can do retrieval augmentation generation to bring in new knowledge. We can give it access to tools, but in reality, what we're really doing when we're doing that is we're actually taking an LLM and creating an agent out of it, because by giving it access to knowledge and tools, these agents now have the ability to have percept about their environment, and they have the ability to take actions, which is the definition of an agent. And today, many businesses are building single agent LLMs. The majority of our customers are taking LLMs and they're grounding it with their own data, and they're giving it the tools that they need for them to take actions and reason over their data. And essentially what they're doing is they are building single agent LLMs. And that way that these LLMs can be specific to a domain or a task. If you look at our co-pilots at Microsoft, right, they're a great example of how you can use agentic LLMs today for everyday tasks, like summarizing your Teams meeting or helping you write a Word document or a presentation, right? In essence, those are all kind of single LLMs that are working to try to help you solve a certain task. But now imagine a multi-agent system. And that is a system comprised of many agents working together in a system where each agent is not only equipped with the ability to learn and adapt, but it also has the ability to communicate with other agents to solve and automate even more complex tasks. So, and we've been at the forefront of this, right? In this evolution, we have frameworks at Microsoft like the Assistance API from the Azure OpenAI solution, or AutoGen, which is an open source research paper that allows you to build these multi-agent systems and can really get customers on the ground quickly in building these really complex multi-agent systems that have memory, knowledge, tools, but also have the ability to orchestrate a full multi-agent system that has multiple agents that are all domain experts or can do different tasks and have them operate in fashion to solve very complex problems. If you're interested, I can show you what these frameworks look like.
Yeah, I was just about to say, all the things you just walked through were great. Conceptually, love to see how this actually works in the real physical world, or how to create an agent or what an agent looks like, and as well as then what does it really mean if you have anything that deals with a multi-agent world. As you're bringing that up, I guess one of the other questions I had for you, Simon, was we hear a lot about um, human reinforced learning on large language models. How does a human interact with agents? And maybe let me be a little bit more succinct in my question. Are humans alleviated or eliminated entirely with agents, or is there some kind of proxy that will work hand in hand with an agent to a human and vice versa?
Yeah, that's a great question. So we always, when we design these systems, we always try to have a human in the loop because, in essence, LLMs are probabilistic models. So sometimes you never know what kind of answer it could come out with, so you always have to have kind of a human reviewer or human in the loop. These frameworks actually facilitate that. For example, AutoGen gives you the ability to have user proxy agents, which when the LLM can't figure out an answer or doesn't know what to do or doesn't have the knowledge, or maybe needs to review something because it's not sure what it's doing, it can actually tap into a human to ask questions or to provide the data or anything necessary to continue the automation task. So of course, we try to automate as much as we can, but in the majority of the cases, we always have a human in the loop in these systems for multiple reasons, for responsible AI, to make sure that the output is accurate and relevant, but also to see if there's anything missing that's part of the automation, right? In certain cases, the agent system might not know how to solve a certain task, so it can actually communicate back with a human to get clarification or things like that.
Got it. Thanks.
Yeah, no problem. So we looked at I talked about two frameworks. There are several frameworks that exist, but let's just focus on two here. The Azure OpenAI Assistant API is a framework that allows you to create these single agents or even multi-agent systems. And it's an abstraction of kind of the things we already know, right? We know about, we know how to do RAG, we know how to do function calling, but this is an abstraction that allows you to basically take a ChatGPT LLM and create an agent out of it. And what we do with this is we have the ability to give these assistants a model, a GenAI LLM model. We also have the ability to give it files, right? Like data, external knowledge, code samples, whatever you like, right? Like you can ground these models really easily just by uploading files to them, and they already have access to this knowledge. We can give them instructions, right, through system messages. We can give them personalities, but we can also give them tools like a retrieval tool to be able to retrieve information from the internet. We can give them code interpreter tools so that they can write code, they can execute code, and we can give them functions so that they can actually call a loyalty database, or, for example, and do certain things. So I really like the Assistant API. It's a really easy framework for you to start taking these ChatGPTs and making them agentic, right? Giving them access to files, models, and tools, and all of that. And it's cool because the Assistant API has a concept of these threads, right? Where everything is persisted in these threads. So all the interactions that the agents have, they all have access to, oh, what did the previous agent output? What kind of data did it use, right? And we persist all that information in a thread. And that gives the ability for these agents to have a very cohesive understanding of everything that's happening and how the agents are interacting with each other. You could use this today on the Azure OpenAI Studio, really easy. You go in there, you can create your agents, you can ground it with your files, give them access to tools, and you're good to go. Maybe a more sophisticated framework. This is an open source framework that was developed by Microsoft Research. It's called AutoGen. It's one of the most popular multi-agent frameworks out there. It's an interesting approach. The way that this framework works is that everything uses natural language to communicate, just like humans do. When we're in a meeting and we're trying to collaborate with a whole bunch of experts in the room, we use natural language to communicate our thoughts or information or whatever. This AutoGen solution actually uses the natural language processing of these models, and they actually communicate through language, right? So it's really interesting. For example, I created a chess application where I had two agents playing chess against each other, and they were having a real, natural language conversation with each other, and even talking about chess and other things related to chess. So it was really interesting to see them having a conversation. And this is what this framework does. And it comes with all of these flexible patterns because there are many ways of architecturing these agents, as you see here. They could be sequential, they could be nested, they could be into groups, they can be into hierarchical chats, they can be competitive, they can be cooperative, right? So there's many ways of designing the solutions. And what this framework does, it really allows you to harness these kind of patterns that we've seen across our customers, and harness those kind of patterns into these multi-agent systems. It's a great framework. I use it all the time to develop like really sophisticated agent systems.
Is it a de facto framework like within Azure AI? If you use those tools, is that what it is, or you have to just design, or you can design in any platform using this framework?
It's a code first approach for AutoGen. There is a studio that you can use to actually do a kind of a low code, no code approach to it. But essentially, it's model agnostic AutoGen and platform agnostic. As long as you have access to an LLM somewhere, it could even be an SLM, like a Phi-3 model, a very small model. You can build these things through code or through the studio.
Awesome. So, any examples? How something in action, Simon. Like this looks great in terms of the theory, but something in action would be awesome to see as well.
Sure. All right. I do. I have plenty of those. Let me show you maybe one that actually wrote a blog post about this one. This actually leverages the Assistant API on Azure that I showed you before. I built all of this using our Azure OpenAI Assistants API. And it's an interesting one. This is a marketing use case where we may have like a marketing department that needs to create images, content for blog post or for a website, etc. And as you know, there's probably a lot of iteration that goes into creating these images, making sure they're branded properly, or that the images are well designed, or are creative and all that. So I had this idea that we could, maybe use a multi-agent system to try to help kind of automate that process. So what you see here is I have this. I have this user proxy agent here, and this agent actually serves as the main orchestrator for this entire agent system. This agent actually has the ability to create a plan based on the assistance that it has at its disposal, or the tools. It provides the agent orchestration, and the proxy assistant could actually, if it's missing information or it requires any feedback or any clarification, it can actually tap into a human to ask questions as well. So this is kind of the main kind of orchestrator of the whole system. But underneath that, I have two agents. I have a DALL-E assistant, and this agent, its specific purpose is to generate image given a prompt. And I have a vision assistant, and this assistant has the ability to look at an image, analyze it, and even critique an image to make it even better. So what I'll show you is how we've built this agent system, and through that, we have the ability to automate image generation and enhancement through these agents. So let me show you that in action. So here, what you'll see is this multi-agent system. And what I'm going to do here is, and you can give it any prompt that you want, right? And for simplicity here, I'm just going to ask this multi-agent system to generate an image of a dog, okay? And what you'll see is it will actually create a plan. It will know that it has access to the vision assistant, and that it could actually analyze this picture and provide feedback to make it even better. So what's going to happen here is we first start off with this query, and the proxy agent is actually going to create a plan based on the agents that it has. And it's going to be a pretty simple plan in this case. the DALL-E assistant is going to create an image. It's going to send that to the vision assistant. The vision assistant is going to analyze that image. It's going to create a new prompt with enhancements. It's going to send that back to the DALL-E assistant. It's going to generate an image. It's going to go back to the vision assistant. It's going to do this in a loop until it gets to a point where it thinks that the image is satisfactory based on some metrics that I provided to the agent system. So the first image that you see here is just the creation of the dog with DALL-E. But then the automation part kicks in here, where now DALL-E says, well, I created the image, and it converses back with the vision assistant, and it says, hey, can you analyze this image and critique it and give me any enhancement to make it better? So what happens is the vision assistant now then takes the image produced by the image creator assistant, the DALL-E assistant, and it analyzes that image. And what you can see here, it actually criticizes this image. It says, this image is well composed and visually appealing, but there is room for improvement. The position of the sun in the background creates a lens flare that can be distracting to some viewers. Additionally, the image could benefit from slightly lower angle to emphasize the dog's leap and create a more dynamic perspective. So what's going to happen now is we're going to take that information and we're going to feed that back to the DALL-E assistant so it can create an even better image based off the image that it was produced here. Let me skip that a little bit and go a little bit further. So it sends that back to the DALL-E assistant, and then DALL-E assistant takes that feedback and generates an even better image with those changes. And of course, this goes on, and the vision assistant again analyzes the image, and it says that it needs more dynamic lighting and texture of the dog's fur, etc. And we send that back to the DALL-E image, and then we get to this beautiful final picture that was fully enhanced and automated by AI.
That's very cool.
That's amazing. That's a real representation of humans criticizing each other and actually improving each other. So, yeah, it's an awesome example.
Yeah, I have another example if you want to see.
Yeah,
Sure.
yeah.
Okay, this is maybe a bit more of a sophisticated example, and maybe an example that represents something more in the real world, right? I was working with a company, an airline company, and they were trying to automate hyper-personalization for customers who had complaints, who had either lost the baggage or had flight delays, etc. And they were trying to create an automation system to be able to create really hyper-personalized emails to customers. And it's more of from a customer representative or an agent assist kind of view, where maybe a customer representative would have access to a system like this to really help them create these hyper-personalized email for their customers. Now, the customer representative can basically ask any information or provide any task that the system would be able to analyze for any customers, right? Of course, the customer representative can be part of this loop. It can review and approve agent actions, and it can communicate back the hyper-personalized email to the stakeholders or have it go through a review process. But in essence, what happens here is this orchestrator agent has the ability to create a plan based on the task that's being given by the customer representative. And the orchestration agent has access to these agents that you see here, right? It has access to an agent that can retrieve and analyze specific information related to a customer. This could be coming from a CRM. It actually has access to customer complaints database, where we have a database loaded with information that has customer complaints from emails, from different social media channels. So it has access to all of that. It also has access to a loyalty agent. So if it deems at one point that a customer may be eligible for a loyalty compensation, it could actually use that system, call that system, and provide the loyalty information to that user. But the idea here is that by gathering all of this information from this customer, we're able to then actually write a really, really hyper-personalized email to that customer based on any complaints that they've had. And we have the ability to even provide them compensation and loyalty points through that email through this agent here. And of course, you can have a critique agent as well that has the ability to review this email, to provide specific company branding guidelines, or any specific things that you would want in this email. And all of this can be automated. So let me show you how that works. I have an example of this, of how this would work.
So let's see this in action. We begin by asking the multi-agent system with the problem we are trying to solve. In this case, we are asking to write a personalized email for John Smith.
How does it mimic the keyboard?
And of course, this could be any customer, and we can do this just by asking a different question with another customer name. In this case, the planner takes the query to come up with the plan to solve the problem. In this case, it will call the complaint assistant to retrieve John Smith's complaints. It will call the customer data assistant to retrieve John Smith's customer data. We'll call the loyalty assistant to see if John Smith is eligible for compensation. And it will take all that information to then generate a very hyper-personalized email. As you can see here.
Oh, wow. Sorry about that.
Custom information.
Bring that back. I click
Date, and it executes a function call to retrieve all of John Smith's complaints. The customer data assistant is then called to retrieve all of John Smith's data from a CRM. Following that, the loyalty assistant is called to take that information to see if John Smith is eligible for compensation based on his complaints and his customer data. And as you can see here, the loyalty assistant adds 100 points to John Smith's current loyalty points to bring John to a new balance of 1,100 points. The email generator then takes all that information and writes a very personalized email to John Smith about his lost baggage, his flight delay in customer services, shortcoming, his seating mismanagement, and the loyalty recognition and the bonus compensation that we've provided to John Smith. As you can see here, this email generator is very hyper-personalized based on all of John Smith's complaints and customer data, including the compensation that we provided as a loyalty recognition member. The email generator then approves the email and sends the email using its SMTP server through a function call, and the email has been successfully sent to John Smith.
Now, of course, this is a fully automated system, but like I said before, right, in essence, you would probably have a human in the loop to verify the email, verify that the data is accurate, and etc. Anyway, so this is kind of the art of the possible, right? Like, I think where there's a lot of value in using these systems is this kind of abstraction, right? Now that you have these kind of domain experts working together, you can really solve much more complex problems, but you can also, with one system, solve a much more wider range of problems, right? Like, I can ask this multi-agent system multiple questions or multiple tasks, and they will be able to execute it because it has access to that knowledge and the agents and the tools to be able to execute the task that we're trying to give it. So, and of course, as you saw here, these agents can communicate with each other and creates, some sort of orchestration or automation through a planning or through task decomposition, and we can bring all of that together to create these really sophisticated multi-agent systems.
That sounds really good, and I love these two different examples. I guess maybe one question I have for you, as we near the end of this episode, is what is the future of agents? What do you see that they may be able to do more than what you kind of walked through today?
That's a great question. Let's recap a little bit what we just talked about, right? We talked about how Gen AI and LLMs have really revolutionized the whole agent kind of automation landscape, right? We talked about robotic process automation and rule-based agents. We talked about how traditional machine learning and reinforcement learning were applied to these kind of RPA agents. But like I said, right, like the Gen AI and using these general purpose models that have a lot of knowledge really kind of changed entirely the landscape of this. And what you can see here is the majority, of our customers are here, right? They're building these, whether they even know it or not. They're taking LLMs and Chat GPT applications, and they're personalizing them. They're using RAG to ground them with their own data. They're using, tools to call different systems in the organizations, and essentially they're creating these single agent systems. Now you can imagine in a company where they have maybe 100 chat GPT applications and they're all expert in different fields of their organization. Well, the idea is that, well, how can I take this and kind of leverage on these siloed single agents and have them work together to solve even more complex problems and create automation through the enterprise in the organization? And this is where a lot of our customers are going, right? They're building these single agents, and then the next question is, how do I combine these agents together so that they can work together? And this is where we get into this multi-agent realm, right? Where now you can use these communication layers to be able to have these agents to speak to each other and solve even more complex problems. And you can have a whole bunch of domain experts working together. Now, of course, whoops. Now, of course, we didn't talk about this very much, but these agents, with models like GPT-4o, where we now have the ability to look at different modalities like audio and, vision or even video, we essentially can give these agents access to other modalities, right? Like you can give these agents the ability to see. We can give these agents the ability to hear. And so we're seeing a lot of that, right? The marketing example where I have the vision assistant and the DALI assistant demonstrates how we can actually give these agents eyes and ears and have them the ability to create images or videos or different things, right? So it's really interesting to see how we were kind of giving these agents these superpowers, right? And seeing what they can do. It's really interesting. And of course, the future of this, it gets to a point where if you're able to create these agents, then why wouldn't these agents have the ability to create their own agents, right? And self-replicate, or what we call agent swarms. And the idea there is that if you give a task to an agent to do something and it doesn't have that agent at its disposal, or it doesn't have the tools or the functions to be able to gather the data that it needs to solve the problem, then why wouldn't the agent not have the ability to actually create an agent that will give it access to these tools and these agents? And this is where it gets really interesting, and you have these self-replicating agents and you have this agent swarm. And we're still kind of on the beginning of this journey, but I mean, there are techniques and ways of creating these self-replicating agents and creating agent swarms to solve even larger, more complex problems that can arise from a system like this.
This is awesome, Simon. One question: not every technology really gets translated into actions and the business value of it, right? I mean, blockchain was one example, and likewise, there have been similar stories as well. Why should business or enterprises really care about this agent? Is it really inevitable? Is it really something worth investing? Is it the right time? Should they wait for it before it matures further?
Yeah, I think we're still kind of the beginning of this, and of course models are evolving to be better and more accurate and more relevant, and we're going to see significant evolution of this in the next couple of months, I would say. But in essence, though, even with, I would say, primitive, technology that we have today, and it's difficult for me to say that the GPT-4o model is primitive, but we can do some really sophisticated agent work, as I've shown you in this podcast, and it's really astonishing for me to see that we can do this today with what we have, and it's really interesting. And I think, like working with customers, I spend the majority of my days working on agents, and the value that we're seeing with the different use cases that we can do with some of our customers is completely mind-blowing. From maybe a more generic perspective, when you use agents, it's a huge kind of interesting transformation journey, right? And it really allows you to create these autonomous agents that can proactively perform tasks for users, eliminating potentially a lot of repetitive tasks in an organization. And I feel that, just that fact, using multi-agent system can really increase the productivity over things like that are repetitive, and allowing employees to focus much more on higher value activities that could require human insight, but why not let the LLMs actually do the kind of repetitive tasks that we do every day, right? And let us kind of be the creative channel to actually create more innovative things. And of course, because these things have the ability to automate and orchestrate, right, they can really minimize the time spent on manual tasks and speeding up operations, and therefore enhance efficiency. And of course, like these things have the ability to make decisions, right? Maybe we don't want to outsource all of that to these agents, but they do have the ability to take certain decisions, right? Provided with the data and the tools that they have. And this could make it really interesting in situations where these agents could operate in outside of normal working hours, right? Providing kind of round the clock service and responses at any time of the day. And ultimately, if these agents can automate tasks, then you can reduce labor costs and operational expenses, and just create better autonomy within an organization.
Yeah, no wonder. I mean, there is so much inefficiencies currently are in the real world. Whether it's like getting an update, whether getting some information, and there's just so much happens that that frustrates the customer or the user. And I think there's so much that agents can actually solve that problem. So
Did
it's
we
it's
lose
going
Jamie?
to
Did I scare him away?
I think yeah, Jamie would miss a little bit of tail end of this conversation, but it was an amazing conversation, Simon. Thank you so much for spending time with us. This is Agent AI. You are doing actually some pioneering work with agents and putting them into the applications. I believe that you have created some projects also on GitHub, etc. Would love to actually share that with our audience as well. So they can actually probably get inspiration or reuse some of the work that you have done on the GitHub as well.
Absolutely. The marketing use case that I showed you, I have a GitHub repo on that, how you can replicate that really easily using the Assistant API. And I mean, just to finish off, it's like, I love this stuff. It's like I'm like a kid in a candy store playing with this technology. It's really fun. So I really hope everybody who's listening to the podcast, can maybe start exploring with this stuff and just have the same passion that I have on this kind of stuff. So anyway, thank you. I really appreciate being able to talk about it on your podcast today. Thank you.
Thank you, Simon. This was great, and I will invite the audience, if they have any question for you as a follow up, they can leave that in the comments, and then we will try to get some answer to those comments from you then.
Great. Thanks so much.
Thank you. Bye.
Thank you.